Hi there, my name is Meghraj Tambaku, and this project is related to the uh, training that I'm doing. This is to build a model combined power plant project which uses combination of gas steam turbines and heat recovery steam generators to generate power. Based on that, we have developed into multiple two models which we have implemented. If on the screen you can see all the data which I have downloaded in terms of the value that was given by the combined power plant project that we have. The data set is already there. There were almost 9,568 observation with 4 features, and we wanted to implement supervised regression model, which is more of a task that I have tried to build, and the target variable is P, which is the power output in megawatts. The primary metric here is root mean squared error that we try to find out and try to explore the data in more detail. Moving on to the next slide, this like overall objective is to use ambient environment data to build an accurate and explainable machine learning regression model actually that estimates power output under different operating conditions. So that's the main aim. Okay, now we'll move to the next plan where the data exploration tab is there. Each observation of this includes 4 ambient variables, which is ambient temperature, exhaust vacuum, the ambient pressure and relative humidity, along with the target variable output in megawatts. The ranges that you see on the screen here is to indicate realistic operating condition, which helps the model to be in the reliable model in that case. Okay, now we have splitted the data. This is a supervised regression problem from what we analyze here, and because the output variable is continuous, the data is split into 60% training, 20% of the validation, and 20% test. The training set it used to fit models, the validation set it used for operating comparison, and the selection and the test is reserved for final performance evaluation. Okay, so that is what we have built it here. If you see what I had explained in the last thing, the split is in training, validation, test. This is how we have split the data. Okay, so that is how you can see it here very clearly. Now, according to this, the first model, that is the baseline multiple linear regression model, using only ambient temperature and exhaust vacuum as an input feature. So only in this case only two things that we have taken. This model provides a simple and interoperable benchmark, achieving a validation of root mean square error of approximately 4.82 megawatts. Okay, and R squared about 0.923. That is what the first model, which is a linear regression model, is what it is coming up to. Having said that, moving to the next model, we have enhanced polynomial multiple linear regression model which we have used. In this, all 4 parameters were used instead of 2. Okay, the 2 parameters were used completely and includes interaction and squared terms such as temperature squared and temperature multiplied by pressure. This model allows to capture the non-linear effects and environmental interaction, reducing validation RMSE to about 4.17 megawatts, which is a 13% improvement over the baseline. So, with more data, I think that is what the second model is. Now, having said that, going through both the model, we move to the third, which is the comparison between the two models and the observations that is coming out of it. So this comparison shows here that the model 2, okay, consistently outperforms the model 2 on the validation test, because the validation error here is low. Model 2 is selected from our perspective as the final model using validation performance for selection, as it helps to avoid overfitting and ensure fair model evaluation. So that is what I think we have done to interpret the final model. Coming to the conclusion that we have already made. Uh, Now coming back to the final value that is been shown here. Analyze the standard coefficients. Ambient temperature at the larger absolute coefficient here with negative sign, confirming that higher temperature reduces power output. An interaction and square terms further indicate that temperature impact is non-linear and it depends upon other environmental conditions which aligns to the physical condition. So overall, this is the project, and RMSE is approximately 4.37 megawatts and R squared value of 0.83. This means that the model explains that about 90% of the variation in power output and generally well to the new data. So that is what it is all about. Thanks. Have a nice day.